Yesterday we looked at exactly outcomes. Today we're going to have at least and at most. So this actually increases your chance of winning. So we have our same formula from the other day. And now let's say this. You've got 3 dice that you can roll. You're going to win if at least 1 2 shows up and you get 3 tries. So here we go. I lost. I lost. Hey, I won! I got 1, 2, and 3 tries. Now, I could also win on multiple levels. So if I think about this, here are my 3 rolls. As long as the 2 shows up here, or here, or here, I win. But it says at least 1. So I could get 2 2s here or here, or I could get the rare case of them all working. So I have to figure out the probability for 1, 2, 3, 4, 5, 6 different situations. And this is what it's going to look like. I'm going to start. How many rolls do I get? 3. C. Well, let's look at 1. I just get my 3 rolls and I get a 2 either in the first spot, the second spot, or the third spot. My probability of not getting a 2 is 5 over 6. My probability of getting a 2 is 1 over 6. I want my 2 to show up once, and I want my other 2 rolls not to be. Figure this all out. Well, 3C1 is 3. 25 over 36. 1 over 6. I get 75 over 216. But I'm not done. Because I can also win if I'm given 3 rolls. At least I can win if I get 2 2s. So now I have to figure this out again. 5 6, 1 6. I want my 2 to show up twice, so my winning probability of 1 6 gets a 2, and then I want my one other chance not to be a 2. So 3C2 is 3 again. 5 6 to the first is 5 6. 1 6 to the second is 136. And I get 15 over 216. And I'm not done yet, because I can win on 3C3, which means my losing probability, my winning probability. I want my 2 to show up on all 3 rolls, and I want no rolls to have a number other than 2. 3C3 is 1. Anything raised to the 0 power is 1. 1 6 to the third power is 1 over 216. And now I add these together, because remember, I can win here, or here, or here. And I'm emphasizing the word or, because in probability, or means to add. So if I add this all up, 75 and 15 is 90. I have 91 in total out of 216 opportunities to win. Now there is a shortcut. 1 or 2 of you may see the shortcut, but until then, you're going to suffer with the long way. Now notice, if I said you roll a 2 exactly once, then this is the only time you can win. 3 rolls exactly once, losing, winning. I want to win once and lose twice. Look how nice exactly is. Exactly means I have exactly one piece of work to do. When you have an at least or an at most, you've got a lot of work to do. Rose is competing in a basketball free throw contest. To win, Rose must be successful in at least 4 out of 5 throws. If the probability that Rose will be successful on one any single throw is 3/4, what is the probability that Rose will win the contest? Okay, slow it down and let's look at our formula. Here's our formula. There it is. Okay, so I know I have to pick out probability. Probability. Success is 3/4. So look, I figured out my winning probability. It's 3/4. So it's kind of obvious what my losing probability is. 1/4. Okay, so I can put them over here in losing and winning. Now, is this an at least or an at most? It's an at least 4 out of 5 shots. So, she's given 5 shots. She has to win on 4. But what if she made all 5? She can still make all 5 and win because it's at least. See, this is the least. So I count up. And I can't go beyond 5 because she's only been given 5 shots. Now, I kind of start making a little pattern here. Losing, 1/4, 1/4. Winning, 3/4, 3/4. Okay, 4. I want to win 4 times, so therefore I want to only lose once. 4 plus 1 is 5. I want to make all 5 shots, so I want to win 5 times, and I want to lose never. Now it's just all math. 5C4 is 5 times 1/4 times, well, 3 to the 4th is 81. 4 to the 4th is 256. Okay, let's get that stray mark out of there. And if I multiply this all together, 81 times 5 is 405. And 256 times 4 is 1,024. On the bottom here, 5C5 is 1. Anything raised to the 0 power is 1. 3/4 to the 5th power is 3 to the 5th power is 243. 4 to the 5th power is 1,024. Add it all up. 648 over 1,024. Okay, just bring my formula in and start it again. Family of 5 children is chosen at random. What is the probability that there are at most, crap, and at most, that means I got a lot of work to do, 2 boys in this family of 5 children? Well, what's my probability? Well, with children, it's 1/2. Boys, it's 1/2. Girls are 1/2. All right. So an at most 2 boys. 2 boys is the most you can have. So 5 kids choose 2. That's what we're going to start with. So since 2 is the most that I can have, I can't have 3. I don't want 3 boys running around my house. That's just disaster. 5C1. I'll take 1 boy, or I'll take no boys, because 2 is the most I can have. Now that that's done, all the work after this is routine. Losing probability. 1/2, 1/2, 1 half. Winning probability, 1 half, 1 half, 1 half. Okay, I want 2 boys. I want 1 boy. I want no boys. All right, if I have 2 boys, 5 kids total, 3 have to be girls. 1 boy, 4 must be girls. No boys, all 5 must be girls. And you see the nice little patterns we have going here? 3, 4, 5, 2, 1, 0. 1 goes up, 1 goes down. Add it all together, multiply it out. Let's see, 5c2 is 10, 1/8, 1/4, 10 over 32. 5c1 is 5, 1 over 16, 1 half, 5 over 32. 5c0 is 1, 1 half to the 5th is 1 over 32. Love 1 half to the 0, it's 1, so I get 1 over 32. So your chances are 16 out of 32. Chances that you have 5 kids and at most 2 are boys. A spinner has 6 spaces whose colors are blue, green, pink, yellow, red, and black, just like they are down here. And this can actually spin. Woo! Hey, I win! What's the probability of spinning at least 1 red in 4 spins? So I get 4 spins, and I see if I can land on red. So I'm going to start, and I have to make my little charts. So I have to get my information, and my information is this. What's my winning probability? I've got 1 red space out of 6 on there. So my losing probability is if I land on anything other than red, which is 5 out of 6. Now, I'm going to win if I can get it red at least once. So I'm going to come over here and I'm going to start setting up my combinations. At least once, which means 1 is the least I can win. I can win on 2, I can win on 3, I can win on 4. So I set myself up 4c1, 4c2, 4c3, 4c4. Now I set up my probabilities, and to save time, there they are, 5, 6, 1, 6, and I set my pattern up. And now I'm just going to start entering my exponents. I want to win once and lose 3 times. This one says I want to win twice, so I want to lose twice. This one says I want to win 3 times, so I lose 1 time. This says I want to win all 4, and this time I want to lose none. Now I can figure out my probabilities. And this is another reason I use Pascal's triangle. So I can get 4c1, 4c2, 4c3, and 4c4 all in one shot, and I don't have to do it on the calculator. If I have Pascal's triangle, I can just go 1, 4, 6, 4, because I can just go to the rows and pick off my answers. I can just figure out the rest of my probabilities. 5, 6 to the 3rd power is 125 over 216, 1 over 6. 25 over 36, 1 over 36. 5 to the 6 to the 1st power, 1 6 to the 3rd power, 1, and 1 6 to the 4th power is 1,296. You should see patterns going on here. If not, we'll talk about them in class tomorrow. Now I just multiply this all out. This ends up being 500. This ends up being 150. This ends up being 20. This ends up being 1. And notice, I know my common denominator is going to be 1,296. That's what I'm going to get on all of these, so why bother writing them down? Add it up, 650, 670, 671 over 1,296. Now there is a much shorter way to do it. Only on this example. You see, there's only one way I'm going to lose, and that's if no red shows up at all. So I know probability has to add up to 1. So if I take away from 1 the only shot I've got at losing, I'll come up with all my winning shots. 1 minus 4c0 is 1. 5 over 6 to the 4th power, 625 over 1,296. Anything to the 0 power is 1. Well, what's 1 minus 625 over 1,296? Well, 1 written as a fraction with a denominator of 1,296 is 1,296 over 1,296, and look what I get when I subtract that. 6 minus 5 is 1. 9 minus 2 is 7. 12 minus 6 is 6. I get the same answer.